Just a bit background about myself. Started out of Nigeria, drilling, downward tools, drilling optimization, worked for Schlumberger for about 4 years, MWD, well placement. So you guys talking about geosteering, well placement, drilling optimization, moved to JA, mostly downward drilling to manufacturing, design, out of Oklahoma, a lot of manufacturing experience there. Currently the Director of Engineering at Bico Drilling Tools, mostly focused on drilling models, shock tools, and drilling jobs. All right, let's delve into the presentation. How will model design respond to these needs? And this is been a buzz. Actually picked this up from JPT journal about this U-shaped well that was drilled last year. And this are some of the challenges the DD industry will keep facing. Higher rate of penetration. We're talking about days versus time. You know, they want to drill faster. We need more torque, more flow through the tools. We're going to be seeing more drilling dysfunctions, stalling of the mod model, stick slip downhole. Now we're talking about the high frequency torsional oscillations. We want more shorter beat to bend. That's something that we're trying to cut down the beat to bend every time we go into the design phase. Dogleg severity. This well will be, I believe it was fun for the DD, you know, on this well. Temperature is going to keep increasing. That's for sure because we're going deeper. We'll also see frictional wear. Dogleg, side forces, side loads will introduce wear into a lot of downward components. And how are we responding to this in the design phase? One thing, go ahead.
Can you talk about the reduced bit bend? Do you see any trade-offs, any negative aspects of ever shorter bit bend?
Yes, one thing it comes down to your, for example, your truss bearing side. You're reducing that bit bend. So in the design phase, you want to introduce races, for example, you know, races and balls. That because your stack is now going to be shorter. That's one thing that in the design phase. So I would imagine you probably want to start going to diamond bearings, you know, into innovating into something that will really carry much weight at very short. So that's something it's posing challenges in the design, you know, in the design phase.
But the technology is there.
It's there. Yeah, the technology is there. And that's one thing I forgot to point out. This well was not drilled with any fancy tool. It was mostly off-the-shelf technology that was used. But as you said, getting into those problems, the cost of design probably will increase because the technology is going to, you know, go up. But the operator is willing to pay for that. That's going to come down to what the customer is willing to pay for too, you know. So one of the things we've been seeing a lot of is increase in torque capacity. The DD and the operators want models with higher torque output. We see a lot of benefit from the even wall technology when we can get higher torque from these power sections. We can also, you know, design power sections with more flow, higher flow output. For the same length of even wall and conventional, you can generate more, you know, more slope of pound foot to PSI as you talk to differential. So we're able to get shorter models, you know, shorter length between 30 to 35 foot of length on the entire mod model. Elastomers will be able to see more than 350. We've been seeing a lot of growth in temperature, pushing the limit on temperature for sure. And the hysteresis on the rubber is reduced because you have less rubber. And One thing for sure is, like we said about customers calling, you have to be able to respond with variety of design for different applications, and that's what's going to be the future. We've also been seeing a lot of model-driven. This is not new, but it's been growing. Model-driven RSS applications where they have the model driving the RSS mechanically and also hydraulically. One of the studies we've been really helping our customers with is to optimize the bypass through the radial bearings. We want to be able to make sure we provide the lubrication and cooling and also generate maximum flow at the bit for the customer. So a lot of studies has been going into this with computational fluid model and dynamic modeling, CFD, and also some physics-based models to help customers. High-strength connections. We're talking about higher torque applications. The model is putting out that much torque. We're going to be seeing a lot of stick slip, downhole, high-frequency torsional oscillations. And the design of the threads, connections, that's to change. We're seeing a lot of double-shouldered connections in our tools. And you don't just throw in a double-shouldered connections. You know, we optimize them with a lot of FEA studies, especially with the axisymmetric FEA procedure, just so we can optimize the connection length, nose diameter, also the stress relief proof. BSR is something very important these days because of that bend on connections. You have to make sure your BSR is also balanced. Fatigue resistance, very, very important. I was talking about FEA just a little bit earlier. We see that high dogleg severity introducing bending stress into the mod motor. With FEA, you're able to optimize, you know, with what part of the model will start seeing bend, different degrees. We introduce those into assembly just to see where the stresses are being induced, you know, and go into design optimization in those areas. Fatigue analysis with most of the materials available we use. One thing is trying to generate that SN curve to determine what the endurance strength or the fatigue strength, especially when you're using non-mag, you know, components also on your tools. You need to be able to determine what the endurance strength. So there is really a lot of you know, effort that the design process is put it into the design process just to match customers, you know, operational parameters, and we'll continue to see those envelopes being pushed. And we love the challenge, we love the innovation, you know, and that's what how we respond to the future of DD. In conclusion, the future of directional drilling is going to continue to push the envelope, operational envelope, and also the DD industry will need mod models to provide performance to match this new operating envelope. Thank you for your time, guys. Any questions?